All right. And I'll just confirm everyone's able to see my screen that I'm
Yes, that's
sharing.
great. Fantastic. Thanks, Brianna.
Great. We'll begin now. All right. Imagine this. You're an assistant deputy minister. Your Treasury Board submission has just been approved, and you've secured funding for an important initiative to improve Canadians' lives. Now that the approval is here, the clock starts ticking. You only have 18 months to deliver on what you've promised and spend the funds you've been allocated. But now you're worried. Why? To deliver your initiative, you have to create new jobs, and these new jobs need to be classified. That means you need to assign a fair rate of pay and occupational group for each one. And there's a very real chance you might blow by your critical path, waiting months and months for classification to be completed. What if I told you that there was a way to speed up the classification process while maintaining its integrity so you could deliver for Canadians? That's exactly what we're here to discuss today. My name is Brianna Smirk, and on behalf of Team 6, I'm presenting our idea, AI-enabled job classification. First, let's take one step back. What's the root of the problem here? What needs to change? First, the problem is not the process of classification, which, yes, is complex but needs to be robust. The Government of Canada's chief operating cost and the chief driver of its success is its staff. Jobs need to be fairly and accurately classified to manage salary costs while recruiting and retaining the right people to deliver on our different mandates. The problem is also not classification advisors themselves. They are highly skilled and trained, having passed a grueling 2 to 3 year accreditation process. So, what is the problem? The real issue is insufficient tools. Classification work keeps getting more complex, yet advisors find themselves spending a lot of time on repetitive and frustrating tasks. We know this because our team ran focus groups with 55 classification advisors across 17 different departments. Here's what they told us, their top 3 challenges. First, job descriptions. Managers must provide these, but they often struggle, and so advisors have to step in, either identifying a pre-evaluated template that could be used or writing a whole new one. Sometimes consultants will be pulled in to write job description, but this can cost thousands of dollars per case and may not even result in shortened timelines. This back and forth can take weeks and weeks. The second big challenge is the relativity study. It's a core part of the job evaluation process. It's when an advisor has to compare the job to be assessed against others to make sure that their decision aligns with that historical precedent. To do so, they have to look into a job repository to find relevant comparative positions. But this can require manually reviewing tens, if not hundreds, of records. As one advisor told us, it's like looking for a needle in a haystack every single time. And finally, rationale writing. Advisors need to prepare a detailed rationale report justifying their decision. However, a lot of the time that they take is spent copying and pasting from standard documents in support of their analysis. It's no surprise that classification is one of the areas of HR that is hardest to recruit and retain staff. But it does not have to be this way. Imagine if an advisor could upload a job description into an AI tool that was able to read through, understand, and pull out the most similar records of thousands of other job descriptions, all in a matter of seconds. Using open source tools and unclassified job description data, we've created a proof of concept of just that. Now imagine that this tool could also support with drafting job descriptions, comparing them, and with report writing. That is the full vision for our solution, the AI Classification Enabler, or ACE. ACE is a suite of intelligent tools that helps advisors make faster decisions by streamlining the most time-intensive parts of the classification process. ACE is 3 different modules. First, a smart search module that can pull out quickly job descriptions by similarity and meaning, reducing days of search time to minutes. Second, it's a job description helper that can either identify a pre-evaluated job description that could be used to help support a manager, or it can draft a whole new one, reducing the need for manual writing or to hire any kind of consultants. And third, it's a rationale writer that can pre-populate key elements of that rationale report for advisor review, helping them spend more of their time on high-value analytical tasks. ACE leverages an existing repository of over 30,000 job descriptions, rationale reports, and other classification documents. We have already secured access to this repository, and we plan to convert it for a format that is more suitable for use with AI by vectorizing it. The vector database that we're going to build will enable powerful semantic search functions and generative AI capabilities. Here's how ACE overlays into the classification workflow. First, it could be used to reduce that back and forth between the manager and classification advisor about the job description, saving over 20 hours of time and/or reducing consultant fees. Next, it could be used during that relativity study part of the process, saving almost a day of time by helping search be done faster. And finally, it could be used in that rationale writing stage, reducing the 17 hours it currently takes by half. So how do we plan to actually develop ACE in an agile and de-risked manner? We've already validated user needs through our extensive focus group of 17 different departments. We've already built a proof of concept. We've secured access to the job description repository and to other classification documents. And we've been offered the use of a sandbox by IBM. Next, we plan to create a MVP, minimum viable product, vector database, and that first smart search module using 15,000 job descriptions. Our goal will be to have advisors test and help us refine this prototype before the challenge finals in December. We then project that the MVP can be scaled up and the other two modules of ACE can be built within 1 to 2 years of development. Of course, no project comes without risks. Here are 4 key risks of ACE and how we are mitigating them even now. First, accuracy. AI can make mistakes. That's why classification experts are central to every single workflow using ACE. The tool aims to augment and support, but not replace their expert judgment. Second, adoption. ACE will only deliver its benefits if the people that we intend to use it, classification teams, actually want to. That's why we've already been engaging deeply, again, running focus group with 17 departments to co-design the tool's features with them to ensure it actually meets their needs and will drive significant impact. We've been building support since the very beginning. We've also aligned ourselves and are collaborating with the TBS team in charge of the classification program overall to ensure that our work aligns with the program's goals and directions. Third, information sensitivity. This is a key strength of our project since the data we're going to pull from for the vector database, job description data, evaluation standards, classification reference documents, is all unclassified information suitable for use with generative AI. However, there are certain exceptions. For example, security organizations like CSIS may have classified information in their job descriptions. These cases would be excluded from our tool. Finally, our scope is ambitious. That's why we're pursuing a modular, phased approach that we can develop each ACE module and determine that it's functioning appropriately and delivering results before going on to that next module. By now, you might be wondering what it would take to actually develop ACE. The answer is less than you might expect. Let's examine both the costing and ROI. We've been working with IBM to come up with a rough estimate of deploying ACE in a private cloud on Canadian servers. We estimate a one-time development cost of $100,000, with then an annual cost of $120,000 for hosting, maintenance, and large language model usage. These costs become even lower when you realize our solution is scalable to virtually all departments in the core public administration. If we assume 70 departments use our tool, that one-time cost becomes $1,400 per department, with a $1,700 yearly cost. And the return on that investment would be substantial. It would mean faster job evaluations. It would mean freeing up the equivalent of $6 million of advisor time that could be used for other high-value priorities like organizational design, which is a key driver of productivity and efficiency. Further, we project we can reduce consultant spending by over $240,000. What this really means is we would be enabling faster staffing and reorganization. It would enable the Government of Canada to more quickly stand up and wind down teams to work on high priority and highly evolving public policy challenges so we can deliver results and programs services faster for Canadians. We hope that you are as energized as we are by the potential of ACE and the potential to enable faster classification decisions for a more agile public service. In closing, I'd like to thank the countless departments who provided support and advice to this proposal, technical experts that we've drawn from, and our Team 6 members who've given up many hours, often over evenings and weekends, to make this pitch a reality. Thank you very much, and we look forward to discussing the AI classification enabler.
Merci beaucoup, Brianna. Thank you for the presentation.